MLOps for GenAI and ML, what actually breaks when you leave the demo stage and how to fix it. Hello and welcome. A machine learning demo is easy to love because it is fast, impressive, and focused on possibility. A chatbot answers correctly in a controlled test. A model flags risk with a neat dashboard. A prototype summarizes clinical notes in seconds. Everyone in the room can see the potential. Then the real work begins. The moment an organization decides to move from proof of concept to production, the conversation changes completely. It is no longer just about whether the model can work. It becomes about whether the system can keep working safely, reliably, cost effectively, and at scale. That is where MLOps changes from a nice engineering discipline into a business critical operating model. And when the system includes generative AI, the change is even bigger. Traditional machine learning and generative AI share some foundations, but the production problems are not the same. The risks are different, the evaluation methods are different, the infrastructure patterns are different, and the governance burden is much heavier. In this video, we are going to unpack what really changes when you leave the demo stage, why so many teams get stuck in pilot, and what leaders, architects, data scientists, and platform teams need to do differently to make ML and GenAI production ready. In the demo stage, almost everything is artificially favorable. The data is cleaner than reality. The user journey is shorter. The edge cases are hidden. The volume is low. The cost is invisible. The stakeholders are patient, and the model is often judged on output quality alone. In production, none of those conditions hold. The system must survive messy data, changing user behavior, outages, security reviews, compliance requirements, and business expectations around uptime, latency, and return on investment. For traditional ML, production maturity usually means building repeatable pipelines for data ingestion, feature engineering, training, deployment, monitoring, and retraining. For GenAI, those steps still matter, but they are only part of the picture. Now you also need prompt management, retrieval pipelines, model routing, safety controls, grounding strategies, token cost controls, human feedback loops, and evaluation methods that can detect subtle failure modes. The move from demo to production is not a packaging exercise. It is a design of the whole system around reliability, accountability, and value delivery. One of the biggest changes is that the unit of deployment is no longer just a model. In classic ML, a fraud model or risk score model may be versioned, tested, and deployed as a relatively stable artifact. In GenAI, the delivered capability is often a compound system. It may include a foundation model, a system prompt, a retrieval layer, vector search, chunking logic, guardrails, tool use, orchestration logic, caching, fallback workflows, and user interface constraints. If any one of those pieces changes, the behavior can change. That means MLOps for GenAI is really system ops for intelligent workflows. Teams that treat the large language model as the only thing that matters usually get surprised. They swap one model version and discover latency doubled. They change chunk sizes and answer quality drops. They expand the knowledge base and hallucinations rise because retrieval precision gets worse. In other words, production behavior emerges from the interaction of components, not from the model alone. Another major shift is evaluation. In demo mode, people often ask a simple question: does it look good? That works for a meeting, but it fails in operations. Traditional ML gives teams relatively mature metrics such as accuracy, precision, recall, F1 score, calibration, area under the curve, and business outcome measures. GenAI generated responses can be fluent, plausible, and wrong. It can be factually correct but unsafe. It can be helpful but too verbose. It can answer one query well and fail on a slightly different phrasing. It can work in English but degrade in another language. It can summarize correctly yet omit a critical detail. So production of GenAI requires multi-layer evaluation. You need task-specific metrics, human review, rubric-based scoring, groundedness checks, hallucination detection strategies, safety tests, latency measures, and cost per successful interaction. Evaluation becomes continuous, not occasional, and it must cover both offline testing and live behavior in the real workflow. This is why many organizations discover that prompt engineering alone is not an operating model. A demo can be built by a talented individual who iterates quickly with a notebook and a few prompts. Production needs controlled change management. Prompts must be versioned like code. Retrieval settings must be traceable. Experiments must be reproducible. Test suites must be automated. Rollouts must be staged. Fallback behavior must be defined. Audit trails must exist. In classic software, teams learned long ago that heroics do not scale. The same lesson now applies to GenAI. If one expert is the only person who understands why the system works, the organization does not have a production asset. It has a fragile dependency. Mature MLOps turns intuition into process, and it turns experiments into governed releases. Data also changes meaning as you move to production. In traditional ML, teams worry about training data quality, feature drift, label quality, and data lineage. Those issues remain essential. In GenAI, you now have at least three data planes to manage. First is model-related data, such as fine-tuning data or evaluation sets. Second is retrieval data, which may include documents, policies, product specs, clinical references, transcripts, or internal knowledge articles. Third is interaction data, including prompts, outputs, user feedback, edits, escalations, and acceptance signals. Each plane has its own life cycle, quality issues, permissions, and compliance implications. A model can be strong but still fail because the retrieval corpus is outdated or poorly chunked. A retrieval corpus can be excellent but still expose confidential data if access controls are weak. Interaction logs can be extremely useful for improvement, but they can also create privacy and retention challenges. Production MLOps requires lifecycle discipline across all of these layers. Governance becomes far more central once the system matters. In a pilot, governance is often delayed because the goal is speed. In production, speed without governance becomes risk. This is especially visible in healthcare, financial services, and public sector settings, where organizations are under pressure to modernize but also must prove trustworthiness, accountability, and workforce readiness. AI adoption needs to move beyond hype toward measurable value, governance, literacy, interoperability, and patient-centered implementation. That broader message applies well beyond healthcare. Production AI requires decision rights. Who approves a model? Who signs off on a use case? What risk tier applies? What evidence is required before release? What monitoring thresholds trigger intervention? What documentation is mandatory? Without clear governance, organizations either move too slowly because everyone is afraid or too quickly because no one is accountable. A crucial production reality is that not every AI use case deserves the same controls. This is where risk tiering matters. A marketing copy assistant and a clinical decision support workflow should not go through the same governance path. A search summarization feature over public product documentation is not the same as an agent that drafts payer prior authorization responses or recommends action in patient care. Mature MLOps creates classes of use cases. Low-risk applications may allow faster experimentation with standard safeguards. Moderate risk systems may require stronger evaluation, human review, and access controls. High-risk systems may require formal review boards, documentation, bias assessment, auditability, and strict escalation pathways. The important point is that governance should be proportionate. Over-control kills innovation, but under-control kills trust. Observability also becomes much harder and more important. In traditional ML, you monitor inputs, outputs, drift, accuracy degradation, infrastructure health, and business metrics. In GenAI, you still need those, but you also need visibility into prompt execution, retrieval quality, context window usage, token consumption, refusal rates, hallucination patterns, tool invocation success, user abandonment, and whether users are accepting, editing, or ignoring outputs. A model may appear healthy from a system uptime perspective while quietly failing the business. Maybe latency is acceptable, but answer quality is slipping. Maybe responses are accurate but too cautious, reducing user adoption. Maybe retrieval misses the right documents when terminology changes. Maybe token costs spike because prompts keep growing. Production observability for GenAI must connect technical signals with user and business outcomes. Otherwise, teams end up monitoring machines while missing the collapse in usefulness. Cost control is another place where the demo stage hides reality. A small pilot with a few users can seem cheap, especially if the organization is using a hosted API and informal budgets. Once usage scales, cost becomes architectural. Token consumption, retrieval calls, re-ranking, embedding refresh cycles, model cascades, and agent loops can turn a clever prototype into an expensive service very quickly. Traditional ML usually has more predictable serving economics once the model is trained. GenAI often has variable inference costs tied directly to usage patterns and prompt design. Production MLOps must therefore include costs as a first-class metric. Teams need to ask whether a task really requires a frontier model, whether smaller models are sufficient, whether caching can reduce repeat work, whether summarization can reduce context size, whether retrieval can be narrowed, and whether a deterministic workflow would solve the problem more cheaply. The question is not just can AI do this, it is can AI do this sustainably at the required service level. The role of human feedback also changes. In a demo, user applause can be mistaken for validation. In production, feedback must be structured. For traditional ML, this may mean capturing correction events, downstream outcomes, or labeled exceptions. For Gen AI, human feedback can be far richer. Users may rate helpfulness, edit responses, select preferred outputs, escalate risky content, or reject suggestions entirely. Those signals help improve prompts, retrieval logic, model choice, workflow design, and policy controls. But there is a trap here. More feedback is not automatically better. Feedback is only useful if it is tied to the task, captured with context, and linked to change management. Otherwise, organizations collect piles of comments without learning anything actionable. Mature MLOps treats user interaction as operational telemetry. Security and privacy are often the moment when a promising demo meets organizational reality. This is where many projects slow down sharply, especially in regulated environments. In production, teams must answer practical questions. Is sensitive data being sent to an external model provider? Are prompts and outputs retained by the vendor? Can confidential documents enter a retrieval system? How are access controls enforced at the document and user level? Can the system leak hidden instructions? Are there prompt injection defenses? What happens if the model is asked to exfiltrate policy content or personally identifiable information? Traditional ML has long required secure data pipelines and access management, but GenAI introduces new attack surfaces because the system is interactive, language-based, and often connected to tools or knowledge stores. The result is that MLOps and security operations can no longer be treated as separate worlds. They have to work as one operating discipline. Reliability engineering also needs an upgrade. A model in production is part of a service, not a science project. That means service level objectives, rollback procedures, resilience patterns, and incident response. For traditional ML, the reliability challenge may be prediction latency, batch window completion, feature availability, and retraining stability. For Gen AI, you add dependency risk on external model APIs, rate limits, context failures, retrieval outages, and non-deterministic output variability. Teams need fallbacks. If the preferred model is unavailable, what is the downgrade path? If retrieval fails, does the system abstain or answer from general knowledge? If confidence is low, does the workflow route to a human? If latency spikes, is there a smaller model or cached response path? Production MLOps means designing for imperfection because real environments are never as stable as prototypes suggest. Organizational structure is another hidden factor. Many teams assume MLOps is mainly a tooling problem. In reality, it is also a coordination problem. To move from demo to production, you need product owners who define the real task, not just the technology. You need domain experts who understand failure consequences. You need platform teams that can standardize pipelines and controls. You need legal, compliance, security, and privacy teams involved early enough to shape design rather than block release at the end. You need operations teams who know how the workflow actually functions under pressure. And you need executive sponsorship that is patient enough to fund the less glamorous work of hardening, integration, and governance. This is why many organizations can build 10 demos but struggle to launch 2 stable services. The barrier is not model intelligence alone, it is cross-functional operating maturity. There is also a major mindset change around value. In the demo stage, success is often novelty. In production, success is measurable improvement. That might mean lower handling time, fewer escalations, better compliance adherence, faster coding cycles, reduced documentation burden, improved search success, fewer denials, or higher first contact resolution. Real deployment is about embedding AI into workflows that matter and proving the outcome, not just showcasing capability. If a Gen AI assistant writes beautiful answers that nobody trusts enough to use, it has not created value. If an ML model predicts risk accurately but cannot be integrated into action pathways, it has not created value. Production discipline starts by defining the operational outcome first and working backward. So, what does a practical production playbook look like? First, narrow the use case until success can be clearly measured. Second, define the risk tier and required controls. Third, establish your system architecture, including retrieval, prompts, model choice, observability, and fallback behavior. Fourth, build evaluation sets that reflect real tasks, edge cases, and policy constraints. Fifth, instrument the workflow to capture quality, cost, latency, and user outcomes. Six, stage deployment with limited audiences and human oversight. Seventh, create a release process for prompts, models, retrieval data, and orchestration logic. Eighth, review incidents and feedback on a fixed cadence. Ninth, only scale after the workflow repeatedly proves business value. This may sound slower than the excitement around GenAI suggests, but it is actually the fastest path to durable adoption. Organizations that skip these steps usually end up circling back to them later, after trust has already been damaged. For leaders, the takeaway is simple but important. You do not need separate worlds for ML and Gen AI, but you do need an expanded operating model. The core ideas of MLOps still matter. Versioning, reproducibility, monitoring, testing, deployment discipline, and collaboration are still essential. What changes is the scope. You are no longer managing only a model lifecycle. You are managing an intelligent system lifecycle that includes language behavior, knowledge grounding, safety, user trust, and evolving governance. Teams that recognize this early will move faster in the long run because they will build reusable foundations instead of one-off demos. The big picture is that leaving the demo stage is not where AI progress slows down. It is the stage where work to produce real value begins. This is the stage where architecture matters, governance matters, data quality matters, observability matters, and organizational discipline matters. Traditional ML taught industry that a good model is not enough. Gen AI is teaching the same lesson again, only louder. The future belongs to organizations that can combine experimentation with control, speed with trust, and innovation with operational rigor. That is what modern MLOps is really about. It is not just keeping models alive, it is making intelligence dependable. Thank you for watching and see you at the next session.